You know that feeling when you glance at a clock, especially one of those classic analog ones with hands, and your brain just
Mhm.
instantly decodes it, like 3:45 p.m., maybe 7:30 a.m.
Yeah, it's almost subconscious.
Exactly. And even a young child, maybe 6 or 7, they pick this up pretty fast. It feels so basic, right?
Yeah.
Such a fundamental human skill.
It really does.
But here's something kind of weird. You take some of the most advanced AI out there today, systems that can write, amazing poetry or create stunning art, compose music.
Really complex stuff.
Totally. But these same super smart AIs, they often really, really struggle with that exact thing, reading an analog clock accurately, or even just reliably understanding a calendar.
It's a strange gap, isn't it? A real blind spot.
Definitely an unexpected one. So in this deep dive, we're going to unpack why. Why is this apparently simple thing so tough for cutting-edge AI?
And what does that actually mean for, how we use AI?
Right. We'll look at the implications and also what researchers are doing to fix it. Think of this as your shortcut to understanding a fascinating, kind of quirky bit of modern AI development.
And we're drawing heavily on research from the University of Edinburgh here.
Yeah, specifically their work looking into AI fails at reading clocks when advanced tech can't tell time. It's really eye-opening stuff.
It really sets up this irony. You've got AI doing things that seem incredibly intelligent, like medical diagnosis support or generating photorealistic images.
Things that feel way harder than telling time.
Exactly. But it falls down on something a kid masters before, middle school. It really shows a big difference in how humans and machines perceive things, especially visually.
You'd think with all that computing power, this would be easy peasy for them, like trivial.
You would, wouldn't you? But the numbers from that Edinburgh study tell a very different story. When they tested AI on identifying clock hand positions, well, they got it right less than 25% of the time.
Wait, less than 25%? That's worse than just randomly guessing, isn't it?
It is. Imagine like your AI assistant making you late 3 times out of 4 because it can't read the clock properly. It's kind of wild.
Wow. Okay, and it's not just the analog clocks.
No, that's the other surprising thing. Even with digital calendars, which you'd think would be more straightforward for a machine, right? All numbers and structure.
Yeah, seems logical.
Even the best AI models still mess up the dates about 1/5 of the time. So a 20% error rate.
20%, that's still pretty high for something so basic.
It is. And this isn't just like some experimental lab AI. The research points out that even the big players, models like Google Gemini 2.0 and OpenAI's GPT-o1 variant they studied, show these, well, hilariously imperfect results, as the source puts it.
Hilariously imperfect. Okay, so it's a widespread issue then.
Seems like it. A real challenge across the board for even the most capable systems.
So why? What is it about reading a clock that just breaks these advanced AI systems? It seems so effortless for us.
Well, the research suggests it's a mix of things, but a big part of it boils down to what you could call spatial chaos, maybe? Or just a visual puzzle they can't quite solve.
Spatial chaos.
Yeah.
Explain that a bit.
Okay, so for us, seeing overlapping hands on a clock, we just get it. We intuitively understand their positions, the angles they make. It's almost automatic spatial reasoning.
Right.
But for an AI, taking that visual information, those overlapping lines, and turning it into an accurate time, that's actually a huge leap. It struggles to connect the visual relationships to the abstract concept of time.
So it sees the hands, but doesn't inherently grasp what the angle between them means or how one overlapping the other changes the reading.
Pretty much. It's like its ability to reason about space and geometry in that specific context just isn't there in the same way. It's more like it's trying to match patterns it's seen before.
Which leads me to think,
Mm-hmm.
is it maybe too focused on pattern matching rather than understanding the underlying geometry like a child learns the rules of the clock?
That's a really good point. And it gets worse because analog clocks aren't all the same, are they? There's huge design diversity.
Oh yeah, definitely. You've got Roman numerals.
Exactly. Or really fancy, stylized hands, different fonts, weird face designs.
Things humans find artistic or elegant.
Right. But for an AI's pattern matching, each one is like a brand new puzzle. It sees 12 and maybe thinks ancient text, not 12 o'clock. Those stylish hands, they might just look like, abstract squiggles it can't decode.
Ah, so the very things that make clocks interesting visually actually break the AI's ability to generalize from the patterns it has learned.
Precisely. That visual inconsistency messes up its algorithms. It's not just matching one standard image.
I can totally see how that would be a nightmare for pattern recognition.
Yeah.
It makes sense that going from just pixels to a precise time gets, like, exponentially harder with all that variation.
And trying to simplify it, like, say, digitally removing the second hand, the research found that doesn't even really help.
Seriously. So it's not just about too many moving parts.
Nope. The problem seems to be more fundamental, interpreting the core meaning of those hands and numbers, especially when they look different every time.
Okay, that's deeper than I thought. And digging into that
Yeah.
interpretation issue, there's something else weird going on with how AI learns this, right? Something called the 10-point Den bias.
Yes. This is where it gets really interesting, and it's a critical flaw, actually. That University of Edinburgh research, it points out that the huge data sets used to train AI are packed with photos of clocks.
Okay, makes sense so far.
But they're often aesthetically pleasing photos. Think product shots, advertisements.
Right, the nice looking ones?
And what time do clocks often show in those kinds of pictures?
Yeah, I don't know. Is there a standard pretty time?
10 past 10, 10-point Ben.
10-point Den.
Because the hands form a symmetrical shape, kind of like a veer
Yeah.
or a smile. It looks balanced and positive.
Huh. I guess I've seen that. So the AI sees tons and tons of clocks showing 10.10.
Exactly. It gets this totally skewed education. It learns the pattern of 10.10 really, really well, but it doesn't learn the underlying logic of how clock hands represent all the other times nearly as effectively. It's biased by the pretty data.
Wow. So it's like teaching someone to read only using sentences that contain the word apple. They get really good at recognizing apple, but struggle with everything else.
That's a great analogy. It's a classic case of biased training data leading to a big gap in actual ability.
Okay, let's contrast that. How do humans learn? Team human, right? Kids usually get clocks by, what, age 6, 7, 8?
Around then, yeah. And how do they learn? Usually direct instruction someone teaches them. They practice, maybe with a toy clock or a real one.
And we just kind of absorb the spatial part, how the hands move together.
Yeah, it seems much more intuitive for us. It's a mix of teaching, practice, and that built-in spatial understanding. Multisensory, really.
That's okay, so that's team human. Then you've got team AI.
Team AI is mostly about that pattern recognition, pulling statistics from those huge data sets. It doesn't really have that explicit spatial reasoning module built in, not like a child develops it.
And it's heavily influenced by that biased data we talked about.
Hugely. So ironically, that preference for the pretty 10.10 smiley face time actually messes up its ability to learn how clocks work generally.
It learns the exception, not the rule. Okay, this is fascinating from, like, a technical perspective.
Yeah.
But so what? Why does this actually matter in the real world? Does an AI needing to read an old-fashioned clock face come up that often?
Well, it's not just about old clocks. It points to a deeper issue with reasoning about time and visual information. And yeah, it has real consequences. Think about scheduling.
Ah, okay. Like AI assistants booking meetings.
Exactly. Imagine your AI assistant reads a time visually, maybe off an image or a document, and gets it wrong. Book something for quarter past confused instead of 3:15 p.m. That could cause real calendar chaos for people, for businesses.
Yeah, I rely on my calendar being right. That would be a nightmare.
And it goes beyond just scheduling meetings. What about autonomous systems? Robots?
Like in factories or warehouses.
Or even autonomous vehicles. If a machine can't reliably tell time, maybe from reading signs or coordinating with time systems, you could end up with, well, punctually challenged robots.
Punctually challenged robots. I like that.
Yeah,
But yeah, I can see how that would mess up logistics or any kind of coordinated action.
definitely. And think about assistive tech, too. Devices meant to help people, maybe with visual impairments, often need to interpret the world, including time cues.
Right, like reading a clock for someone.
If those systems are unreliable with basic time reading, it really limits how helpful they can be. It erodes trust.
Okay, I see the connections now. It seems like until AI nails this, its integration into a lot of everyday stuff that depends on time, it's going to be, well, limited. Or even, like the source said, laughably limited.
It's a definite bottleneck, an embarrassing one maybe, but a critical one to solve for seamless integration.
But it's not hopeless, right? Researchers are working on this. Operation Time Fix you mentioned?
Absolutely. They know it's a gap, and there are clear strategies. One big one is fixing that training data problem.
More diverse data, not just the pretty 10.10s.
Exactly. The idea is to feed AI literally thousands, maybe millions, of synthetic clock images. Computer-generated ones showing every possible time combination, every variation.
Ah, so flood it with unbiased examples covering everything.
Precisely. Get rid of that 10.10 bias by overwhelming it with correct data for all times.
Okay, what else? You mentioned spatial reasoning earlier.
Right. Another approach is to actually build specialized modules into the AI. Components designed specifically to understand geometry angles, positions, relative motion, more than just pattern matching.
So give it a dedicated brain bit for understanding space.
Sort of, yeah. Building in a more fundamental geometric comprehension.
And for the calendar issues, the 20% error rate?
That needs what you might call a calendar boot camp. Basically, intensive training focused specifically on data arithmetic, time zones, scheduling logic, making sure it has robust, explicit rules for temporal calculations, not just relying on pattern matching there either.
So better data, better spatial understanding, and specific logic training. Makes sense.
Yeah, it's a multi-pronged attack on the problem.
There was that quote from Rohit Saxena at the University of Edinburgh. It really summed it up well.
Oh, yeah, the one about people learning it easily.
Yeah. He said, most people can tell the time and use calendars from an early age. Our findings highlight a significant gap in AI's ability to carry out what are quite basic skills for people. And then he added the kicker. AI can write poetry about time, but can't actually read it. The irony is delicious.
It really is the perfect summary, isn't it? It captures that core contradiction. It's not lacking creativity or language skills.
No.
It's lacking something we see as, well, fundamental reasoning about the physical world and time. It shows there are still these boundaries in what AI can intuitively grasp.
Okay, so let's quickly recap this deep dive. We've seen AI's surprising, almost baffling struggle with reading analog clocks and even calendars.
Yeah, a real unexpected hurdle.
And we dug into the why, that spatial chaos, the visual variety messing up pattern matching, and crucially, that sneaky 10.10 bias in the training data from all those pretty clock photos.
That smiley FaceTime really causing problems.
Totally. And we touched on why it actually matters, the potential for scheduling disasters, issues for robots and automation, limitations for assistive tech. Basically, hindering AI's smooth integration into our time-based world.
Real-world consequences, definitely.
But the key takeaway seems to be, this isn't like a fatal flaw, it's a solvable problem.
Absolutely. It's an embarrassing gap, maybe, but it's a clear target for development. Better, more diverse training data, building in better spatial reasoning, dedicated calendar logic. AI can learn this.
It just shows the journey towards truly general, robust AI that works seamlessly in the real world.
Yeah.
Well, it's still ongoing. There's still fundamentals to master.
Exactly. It's still a work in progress.
You know, as the researchers work on fixing this, it kind of makes you pause and think about us. About that subtle, almost invisible human magic. Our own intuition for space and time. The way we just get these things, often without really thinking about how we learn them. Telling time, processing weird visual stuff, understanding how things relate in space.
Things we totally take for granted.
Yeah. And to make you wonder, what other simple human skills, things that feel effortless to us, might still be way beyond AI's reach right now? How much more complex is our own understanding than we even realize? Something to think about.